Okay, to conclude this lesson on sequences and series, we'll do so by using two examples of factorial expressions so we can learn how to simplify these expressions in a quicker way than to write everything out. Well, we know factorial means from the earlier side of the board to take a number and then multiply by the number that came before it times the number that came before it, etc., until we reach 1. And so for n factorial, that would be n times n minus 1 times n minus 2 until we reach the 3 times 2 times 1. And once we're at 1, we stop. So for 25 factorial, we could go 25 times 24 times 23 times 22 times 21, etc., all the way down to 1. And do the same thing for 23 factorial. 23 times 22 times 21 times 20 times all the way down to 1. But since the bottom 23 factorial is contained as part of 25 factorial, then we don't need to continue these all the way down to 1. We only need to continue them until we see a common factor of factorials. Those will cancel, leaving 25 times 24, which equals 600. Understanding this allows us to do more abstract expressions even quicker. N plus 2 factorial would mean n plus 2 times n plus 1 times n minus 1 times n minus 2 times n minus 3 until we reach times 3 times 2 times 1. Well, the bottom of this expression is n factorial. So it's only necessary that I go n plus 2 times n plus 1 times n factorial, because that'll contain all the rest of the factors that this contains. They cancel. That leaves simply n plus 2 times n plus 1 as the final expression for what we had originally here. It's not necessary to distribute this and call it n squared plus 3n plus 2. If you do, that's fine, but it's not necessary. All right, this concludes it. This is introductory. There is more material in the section of 9.1 that we will do, but for the most part, this is the highlights of the work for this section that we will most likely conclude our course with. See you in Zoom next week.